Hello kings and queens, welcome back to the channel. So in this video today we are going to discuss about a special kind of transportation problem, that is Hungarian method. So this Hungarian method is also known as assignment problem. So without any further delay, let's get started. So before starting the problem, let's have a brief introduction about this Hungarian method. So Hungarian method or the assignment problem is a special kind of transportation problem. So the main objective behind this assignment or Hungarian method is to minimize the time which is required to perform the job by a machine or by a operator. So this Hungarian method helps to identify the minimum time to perform a job by a machine or by a person who is known as operator. Okay, so let's start the sum. So this is the question. So 1 2 3 4 and 5 is a job, and A B C D and E is a machine, and the values inside the matrix are the time which is required to perform the job. So using this Hungarian method we will be identifying the minimum time to perform the jobs by the machines. Okay, so in this assignment problem, there are two types of problem. The first one is balanced and the second one is unbalanced problem. So in northwest corner, Ogle's least cost method, Modi method and all, we used to identify whether the sum is balanced or unbalanced by checking the demand and supply. So if the demand and supply is equal, then it is a balanced problem. If the demand and supply is not equal, then it is an unbalanced problem. But in Hungarian method, we have to identify whether the column and also the row is equal. So in this sum, the number of rows is 1 2 3 4 and 5. So the number of column is 1 2 3 4 and 5. So the number of rows and the number of columns is equal, then it is said to be a balanced problem. If the number of rows and the number of columns is not equal, then it is known as unbalanced problem. So in case of unbalanced problem, we have to add some dummy row or dummy column in order to convert it to a balanced problem. So this is a balanced problem because the number of rows and the number of columns is equal. Therefore, it is a balanced problem because the number of rows is equal to number of columns. So we are done with the first step. So the first step is to identify whether it is a balanced problem or unbalanced problem. If it is a balanced problem, the number of rows and the number of columns will be equal. So this sum is a balanced problem. So the second step is to identify the minimum values in the rows and the column. So first let's do the row minimization. So row minimization. So row minimization is nothing but we have to identify the minimum values in each rows. So this will be our rows, right? So in each rows we have to identify which is the minimum value. So in the first row the minimum value is 7. So among 9, 11, 14, 11 and 7 the minimum value is 7. So I will write 7. So in the next row the values are 16, 15, 13, 13 and 10. So among this the least value is 6. In the third row the values are 12, 13, 6, 8 and 8. So among this the least value is 6. So in the fourth column the values are 11, 9, 10, 12 and 9. So among this the least value is 9. We have 2 9. We can consider any one. So 9. So in the fifth row the values are 7, 12, 14, 10 and 10. Among this the least value is 7. So the second step is we have identified the minimum values in the row. So for the third step we have to write the matrix same like the question. Okay, so let me mark the job and machine. 1 2 3 4 and 5. The machines are A, B, C, D and E. So this is jobs and this is machine. So now what we have to do is we have identified the row minimum, right? So we have identified the least value in each row and we have noted it. So from this values we have to deduct the other values in the row. For example, so now the minimum value in the first row is 7. So we have to deduct each values in this row. 9 minus 7, 11 minus 7, 14 minus 7, 11 minus 7, and 7 minus 7. So like this, from this row minimized values, we have to deduct the values inside the matrix. So 9 minus 7 is 2. 11 minus 7 is 4. 14 minus 7 is 7. 11 minus 7 is 4. 7 minus 7 is 0. So this is the row minimization value. You can write the heading as row minimization. So the second row, in the second row, the least value is 6. So from the 6, we have to deduct all the values. So 6 minus 6 is 0. 15 minus 6 is 9. 13 minus 6 is 7. And 13 minus 6 is 7. And also 10 minus 6 is 4. So then the next row, the minimum value is 6. So 12 minus 6 is 6. 13 minus 6 is 7. 6 minus 6 is 0. 8 minus 6 is 2. And 8 minus 6 is again 2. So in the fourth row, the minimized value is 9. So 11 minus 9 is 2 and 9 minus 9 is 0, 10 minus 9 is 1, 12 minus 9 is 3 and 9 minus 9 is 0. In the fifth row, the least value is 7. So 7 minus 7 is 0, 12 minus 7 is 5 and 14 minus 7 is 7 and 10 minus 7 is 3 and 14 minus 7 is 7. So this is the row minimization values. Okay, so in the next step, what we have to identify is, we have to identify the least value in each column. So for example, in the A column, we have to identify the least value. In B column, we have to identify the least value. In C also, we have to identify the least value. In each column, we have to identify the least value, not from the previous matrix, but from the row minimized matrix. We have to identify the least column values. So in the A column, the least value is 0. So among 2, 0, 6, 2, 0, the least value is 0. So in the B column, the least value among 4, 9, 7, 0, 5 is 0. In the C column, the least value among 7, 7, 0, 1, 7 is again 0. In the fourth column, among 4, 7, 2, 3, 3, the least value is 2. So in the fifth column, among 0, 4, 2, 0, 7, the least value is 0. So this is a column minimization. So this is the column minimization value. So this is our third matrix. We are done with the column minimization. That is, we have identified a minimum values in the column. So now in this matrix, what we have to do is, we have to write a modified solution. That is, we have to write the values after deducting this minimized values from the column. So let me write the same matrix: 1, 2, 3, 4 and 5. This is jobs and this is machine. A, B, C, D and E. So like the row minimization table, we have to do the same procedure in the column minimization even. So in the column minimization, what we have to do is, we have to deduct all the values from the 0. So 2 minus 0 is 2. 0 minus 0 is 0. 6 minus 0 is 6. 2 minus 0 is 2. 0 minus 0 is 0. So for the next column also, we have to repeat the same thing. 4 minus 0 is 4. 9 minus 0 is 9. 7 minus 0, 0 minus 0 is 0. 5 minus 0 is 5. So in the next column, 7 minus 0 is 7. 7 minus 0 is 7. 0 minus 0 is 0. 1 minus 0 is 1. 7 minus 0 is 7. Fourth column, 4 minus 2 is 2. 7 minus 2 is 5. 2 minus 2 is 0. 3 minus 2 is 1. 3 minus 2 is 1. 0 minus 0 is 0. 4 minus 0 is 4. 2 minus 0 is 2. 0 minus 0 is 0. 7 minus 0 is 7. So this is the column minimized table, column minimization. So this is first matrix, this is second matrix, and this is the third matrix. Okay. So the next step is row scanning and column scanning. So row scanning and column scanning is nothing but we have to identify the zeros in the each rows and also in the each columns. If we find zeros in the row, we have to strike off that particular column, and if we find zeros in the column, we have to strike off that particular row. Okay. And if we have more than one zeros in the rows or in the column, so let me show it practically. In this row, we have only 1 0. So you have to square it like this. You have to mark it like this. As we have found 0 in the row, we have to cancel that particular column where we have got 0. I will explain you again. So in this row, we have 1 0 value. So we have marked it. Okay, after marking that, we have to deduct that particular column. For row, we have to deduct that particular column where we have got 0. Okay, I will strike off that. I will delete this. Okay, in the second row, again we have 1 0. Among 0, 9, 7, 5, we have 1 0. So I will mark that and I have to deduct that particular column. Okay, in the third row I have 2 0, so I should not take it into consideration. If I have 1 0, I can delete that particular column. I have 2 zeros, so I will not consider this. Next, let me shift to the next row. In this row, 0 1 1 is the value. Among this, I have just 1 0. You might think like there is another 0, but it is a deleted 0. So it comes under the deleted column. So we should not consider that. I have 1 0. So I will delete this particular column. Okay. Let me shift towards the fifth row. In this row, there is no 0 because the values are 7 and 1. So there is no 0. I will leave that. Now I have did the row scanning. Now again I have to do the column scanning. So in this column, there is no 0. I have cancelled this column. Next column also I have cancelled. In the C column I have 1 0. So I will mark that. I have found 0 in the column. So I have to deduct the row. For row I have to deduct the column. For column I have to deduct the row. You have to think in an opposite way. So in the next column there is no 0, and also in the next column I have cancelled it. Okay, now what we have to do is we have to check whether it is a optimum solution or not. So if we want to get a optimum solution, the number of squares and the number of rows must be equal. So the number of rows is 1 2 3 4 and 5. So the number of row is 5, and we have to count the number of squares here. The number of square is 1 2 3 and 4. 5 rows and 4 squares, which is not equal. So now what I have to do is I have to find out the minimum values in the left out value. So the left out values are 7 2 7 5 1 1 7 1. So these are the left out values. So among these left out values, the least value is 1. We have 1 for 3 times, so I can select any one. I will select this one. So among left out values like 7 2 7 5 1 1 7 1, the least value is 1. So I will select this 1. So keeping this 1, so next what we have to do is we have to add this 1 to the intersecting points. So intersecting points is nothing but where the row line and the column line meet each other. So this is the intersecting point, this is the intersecting point, and this is also a intersecting point. There is no intersecting points because two lines have never joined here. So here it is an intersecting point because two lines have joined here, horizontal line and vertical line has joined here. So 672 is an intersecting point. For 672 I have to add this one. So if I add this 1 to 6, it will become 7, 7 will become 8, 2 will become 3. And for the remaining values like 7, 2, 7, 5, 1, 1, 7, 1, I have to deduct this 1, which means I have to subtract it. For 7, if I subtract this 1, it will become 6, 2 will become 1, 7 will become 6, 5 will become 1, 1 will become 0, 1 will become 0, 7 will become 6, and 1 will become 0. And the remaining values like 2 4 0 9 2 0 0 5 0 4 0 7 and 0 will remain the same. There will be no change. So the change which we have to do is the intersecting points and the values, remaining values, which is not affected by the row scanning and also the column scanning. So let me do that. So this is the fourth matrix. Let me mark it 1 2 3 4 and 5. A, B, C, D and E. Okay. So this is the least value. I have to add this to the intersecting points, that is intersecting values, and for remaining values I have to deduct it, and for these values I have to keep it as C. Okay, for differentiation I will write in a red pen just for your understanding. Okay, so 6 is the intersecting point because the vertical line and horizontal line has met each other. For this 6 I have to add this one. So 6 plus 1 is 7. Okay, and this is also an intersecting point because the row and also the column line has met each other. So 7 plus 1 is 8. And there is no intersection here, there is no intersection even here, so there is an intersection here. So 2 plus 1 is 3. Okay, so the remaining values which is not affected by the row scanning and also the column scanning must be deducted by this one. So 7 is not affected by row and column scanning, so 7 minus 1 is 6, and also 7 minus 1 is 6. 0 is affected by the column scanning, so let's ignore it. And 2 is not affected by row and column scanning, so 2 minus 1 is 1. 5 minus 1 is 4, and this is affected by the 1 minus 1 is 0. So the remaining values must be written like that only, just the values which have only single line. Okay, 2 is having a single line, 4 is also having a single line, 0 9 2 0 0 5, and this is also having a single line, so it will not be affected by anything, 0 0 and 0 4. It has intersected, so we have added, it has become 3, and here also 0 7. Okay, now what we have to identify is, again we have to do the row scanning and column scanning for the modified values. Okay, so in this first row we have 1 0, so I will mark that as square. For I have got 0 in the row, so I will cancel this column. And in the second row again I have 1 0, I have got 0 in the row, so I will cancel that column. In the third row I have 2 0, so I will ignore it. In the fourth row I have 3 0, so I will ignore it. In the fifth row I have two zeros, but this 0 is cancelled, so I just have 1 0 now, so I will mark that 0 and I will cancel this column as well. Now I have to do the column scanning. Column means like this, right? So this column is striked off, it is deleted, so let's not focus on this. B column, in B column I have 1 0, among 4 9 8 0 5 I have 1 0, so I will mark that 0. I have got 0 in the column, so I will deduct this row. Okay, so in the third column I have 1 0, among 6 6 0 6 I have 1 0, so I will mark that 0, and I have got 0 in the column, so I will deduct that row. Okay, fourth column has been deducted and the fifth column is also deducted. Now we have to see how many squares we have. We have got 1, 2, 3, 4 and 5. 5 squares we have got, and the number of rows are 1, 2, 3, 4 and 5. So the number of squares as well as the number of rows are equal. So now we have attained the optimum solution. So if we want to attain the optimum solution, the number of rows and also the number of squares must be equal. Okay, we have got optimum solution, and finally what we have to do is, so which job is performed by which machine and how much time is took by that machine to complete that particular job. So we have to find out this. So this is job, machine and time. So we have jobs like 1, 2, 3, 4 and 5. So the number of jobs are 1, 2, 3, 4 and 5. Okay, so we have to look at the final matrix, that is fourth matrix. So this is the final matrix where we have got a optimum solution. So in order to identify the machine and time, you have to see this matrix. So the first job is done by the E machine. So the first job is performed by the E machine. Okay, so first job is performed by the E machine, and second job is performed by the A machine. You have to see the square where you have drawn. So the second job is performed by the A machine. So 2 is A. And the third job is performed by the C machine. Okay, the third job is performed by the C machine. And fourth job is performed by the B machine. Okay, fourth job is performed by the B machine. So 4 is B. And fifth job is performed by the D machine. So fifth job is performed by the D machine. So 5 is D. Now how we have to find out the time is, for identifying the time you have to see the first matrix, that is the question matrix. Okay, the first matrix you have to identify. So the first job is performed by the E machine. So the first job is performed by the E machine. So the first job is performed by the E machine at the time 7. So this is the time. So the first job is performed by the E machine at the time 7. You have to identify the values like this. So you have to go straight to the 1, and also you have to see which is there below the E. So one job is performed by the E at the time 7. So 7. Next, second job is performed by the A. So second job is performed by the A. Second job is performed by the A at the time 6. Okay, second job is performed by the A at the time 6. So 2 is 6. Third job is performed by the C machine at the time 6. Okay, C is 6. And fourth job is performed by B. Fourth job is performed by the B machine at the time 9. So fourth job is performed by the B machine at the time 9. 9. Okay. 5 is performed by the D. Fifth job is performed by the D machine at the time 10. So fifth job is performed by the D machine at the time 10. So 10. So how you have to see is fifth job, D machine, and you have to go straight to the 5 and straight come down to the D. So the intersecting point is 10. So we have to write the 10 here. Now in order to identify the total hour took by the machines to complete all the jobs, and finally you have to identify the total minimum time which is took by the machines to complete all the jobs. For that what you have to do is simply you have to add all the time. So minimum time is equals to 7 plus 6 plus 6 plus 9 plus 10, which is equals to 38 hours. You have to mention it as hours. So this is all about the assignment problem. So first what you have to do is you have to identify the minimum row values. Minimum values in each row. After that, keeping that value, you have to deduct it and From the second matrix, you have to identify the column minimization, that is minimum values in each column, and after that you have to do a modified solution, that is you have to write down the minimized values after deducting the column minimization, and after that you have to do the row scanning and column scanning, and at the intersecting point you have to add the least values from the values which is not affected by the row and column scanning, and for the remaining values you have to deduct it, and the remaining values which is just affected by the one line you have to write the same value, and finally what you have to do is you have to identify the time and also the total minimum time which is took by the machines to complete that job. So it is a very simple problem. I hope you all like this video. If you like, do subscribe to Kingmakers and share this with your friends. Have a nice day. Thank you all.